Right, so good morning, everyone. For today's lesson, we're going to discuss under column. Okay, we will going to discuss the balance loading. Okay, so balance loading on column. So it is similar, right, to the beam, the balance design for the beam. All right, so I will discuss this while we're going to while solving the problem. Okay, the example here, as you can see. So let me check first, no? Right, yung okay. Okay, so let's remove this one. Right, so let's see if you see it and the audio is okay. So the audio is okay. So we can now start. So again, so this is balance loading. All right. So it is similar to the balance design in beam. So in balance design in beam, if you remember, so it is under balance design if the compressive stress in concrete reach or yield, that is 0.003, okay, okay, will yield at the same time the steel yields. Okay? So, yun yung balance design, di ba? Sabay na mag-yield ang concrete at yung steel. So, it is, the principle is the same here in the column. Right? So, ito yung tinatawag na eccentric loading, no? Yung merong moment, merong uh, concentrated load. Okay? Sa column. So, as you can see here, the figure, okay, we have here the figure. Alright? So, ito yung column natin is a rectangular column, as you can see here. So, meron siyang 6, no? 6 na 32 mm as the problem stated. Okay? And then, yung strength ng concrete natin, okay? So, ang strength ng concrete natin, let's write the given here. Okay? The strength of the concrete is 21 megapascal. Okay? And then, let's say F prime C is 21 megapascal. Right? And the yield strength for our, you call that, Fy, yes, of the steel, 414, yeah, megapascal. Okay. So, ang tinatanong dito, class, the required here, so this is balance loading. So, the required is for us to determine the Pn balance, right? And the E balance, the EB. Okay? So, ito yung required na dalawa. Okay? So, as you can see here, ito yun. No? Ito yan. Ito yung sa figure natin. And then yung PB na hinahanap ito, this one. Ito yung ating nominal balance loading. Okay? This is PB. Okay? So, andito siya sa point na to, which is EB distance from H. Okay? Take note. Ito yung na-lesson natin. Okay? In the previous topics. We need to know first kung nasan yung plastic centroid. As you can see, this is symmetrical column, okay, along this direction. So, therefore, nasa gitna po yung ating plastic centroid, the PC. Okay? So, the E balance is from the PC up to the nominal balance load. Okay, yan yung ating EP. Ito yung hinahanap natin. Alright? Okay, so let's go to the solution. Okay? Before we discuss how to solve PB and EB, okay, so kunin na natin muna yung mga value, okay, na kinakailangan natin. The first one value is the beta 1. Okay? So, 81 is 0.85. Okay? Tama ba? Because our f primes is only 21. Right? And then, also we get, okay, we need to solve AS1. As you can see, sa balance loading, I'm going to draw it. I will draw the elevation of this column, right? As you can see, ito po yung magiging tension side. This is T1. And ito yung compression side. So this is C2. Ang magiging C1 natin class will be ito yung manggagaling dun sa concrete. Okay, take note, dahil may eccentricity na to, okay, it will act like a beam. So ito na yung ating A. Okay, this is the A distance. A balance, no? And then we have also the C balance here. CB. Alright? So, meron kakaroon tayo dito ng another compressive force which is dagan pa natin yung thickness. Yeah. This is C1. Right? So, because of the PB here. Okay, the PB. Right? So, ito yung free body diagram, FBD, ng ating mga forces dun sa ating column. Alright? Kasi nandito yung moment natin. So, dito, balance loading, we expect na sa side na to, away, okay, from the PB, is the tension side. Alright? The tension side. So, we're going to draw the strain diagram. Okay, the strain diagram. Lagyan natin ibang kulay para makita nyo. Okay, let's say blue. Okay, the strain diagram will be like this, no? Parang sa beam lang din. Parang sa beam. Right? This one. Ito yung strain diagram natin. Yan. Right? Okay? So, ngayon, tuloy natin, no? Tuloy natin. So, as you can see here, AS1. So, ang AS1 natin will be yung area ng steel sa tension side. So, itong side na to, no? Okay? So, as you can see here, itong side na to will be under compression. Okay? So, let's have a shading here. Ito yung under compression na part, no? Okay? Under A distance. Pero under compression hanggang sa CB. Right? Hanggang CB yung compression. Take note, ha? Okay? Hanggang CB yung ating magiging compression side. Okay? Pero sa concrete, okay, dun sa, naalala nyo yung compressive block, okay, hanggang A lang yung consider natin. Okay? So, hanggang dyan. Right? And then, dito na sa natitira will be in tension, no? Okay. May hopefully maliwanag. So, ang consider lang natin for AS1 is yung tatlo. Right? So, tatlo lang. Tatlo na 32 mm. bar. Right? So, AS1. So, tatlo. So, that is 768 pi. Okay? So, lagay lang natin dito, 768 pi. As you can see, our AS1 is equal to our AS2. Ang AS2 naman natin, yan yung area dun sa compressive side. Okay? Okay, dun yung uh, dun magagaling ating C2. Okay? Okay? So, that is uh, also 768 pi. Bakit 768 pi? Dahil tatlo rin naman yan. Alright? Okay. Okay, next. And then, our total area of steel, AST, is 2 times 768 pi. So, that is 1536. Okay? That's 1536 pi. Right. So, next na gagawin natin is we determine yung AB. Okay? To get AB, we need to get first, okay, the CB. So, what is the formula again for CB? If going to remember that, no? That is 600D all over, okay? Ayun? Yes, 600 plus Fy. Right? So, nanggaling yan doon sa ating strain diagram. Tama ba? If matatandaan nyo, no? Alright. Okay? Yan. 600D all over 600 plus Fy. Lagyan mo lang yung mga value para makuha natin CB. Yung D natin, what is our D? Class. Okay, our D here is ito, di ba? From the extreme compression side up to the tension steel. Tama ba? Okay, so that is 600 minus 65. Tama ba? The total width, the total depth, okay, minus 65, that is our effective depth. Okay, 535. Okay, so this is 535. Right? So that is our D. So lagyan lang natin dito, 600, 535. Okay, all over 600. What is our Fy? 414. So we will have an answer of, okay, please compute with me. Okay, so that is 316.57 mm. Okay, 316.57. And then we will get now, or we can get now, the AB. Okay, so that is beta 1 CB. Okay, that is 0.85 times 316.57. So we will have, let's check first if nagre-record pa rin yung video natin. Yes, nagre-record pa rin siya. Yes, so 0.85 times 316.57. We will get 269.08 mm. That is our AB. So let's AB. Alright? Okay. So next now, we need to check. Okay, so dito sa balance loading class. Okay, sa balance loading, we know na yung stress sa contention steel natin is equal to Fy. Tama ba? Okay, equal to Fy. So, for T1, we can get the force for T1 now. So, balance loading to Okay? Take note, balance loading, ibig sabihin nag-yield yung steel kasabay ng pag-yield ng concrete. So that's A1 now, or the T1 now, will have a formula A1 Fy o AS1 Fy. Okay? Ulitin natin. So AS1 Fy. Okay? So bakit Fy? Kasi nag-yield nga. Okay, sa tension side. That's our T1. Okay? So that is 768 pi times 414. Okay? Huwag niyo kalimutan i-divide ng 1,000 para maging kilonewton. Okay? So that is 768 pi times 414. Divide natin ng 1,000. That is 998. So 998.88. Okay? Kilonewton. Right? So that is our T1. Okay? For C1 naman, C1. Okay? For the compressive force, okay, due to concrete, or compressive force of concrete, C1, so we will have the formula, the stress, 0.85 F prime C, tama ba? Times the area, A times B. Okay? So that is 0.85 F prime C is 21. What is our A? Ang A natin is our AB here. It's 269.08. Okay? Multiply natin ng width. That is 450. Tama? Itong area na to, no? This area. Okay? And divide it by 1,000. So our C1 is equal to, so what our C1 now? So 0.85 times 21 times 269.08 times 450 divided by 1,000. So we have 2,161.39. Okay, kilo ton. Okay, 2,169.39 kilonewton for our C1. Now, for C2, ito na yung compressive force of our compressive bar. Okay, yung AS2. Ngayon, we need to check if yung gagamitin nating stress is Fy. Tama? So, we need to check if compression bar yield. Okay? So, how can we check that? Yes. From the formula Fs prime. Tama? That is 600 D, or sorry, C minus D prime all over. Tama ba? Ulitin natin. 600 C minus D prime. Yes, all over C. Okay, if matandaan nyo, no? Yes. Yan. Doubly reinforced, no? Okay. So, that is 600. What's our C? Yun natin CB. Tama? So, that is 316.57. Minus D prime. What's our D prime? D prime is 65. Okay? Even na yan. Lagyan natin dito. Lagyan naman dito. D prime is 65. Okay? And then, all over C, 316.57. So, what is Fs prime? So, that's 600. 316.57 minus 65 all over 316.57. So that is 476.80. Okay? Mega Pascal. So as you can see, our Fs prime is greater than, okay? Greater than our Fy. So therefore, still yields. Tama ba? Still yields. So therefore, for our C2, it is AS2 times FY kasi nga nag-yield siya. So that is 768 pi tama, times 414 divided by 1000. You will get the same value as T1, so 998.88 kilo Newton. Okay? So, ito na yung mga force natin. Okay, so the value of PB now, we can now solve the value of PB. Okay, so as you can see, ito yung force natin. T1, C1, C2, and PB. Okay, so summation forces along the y-axis is equal to 0. So let's say positive upward, we have C1 plus C2, right, is equal to PB plus T1. So we will get the value of PB now, that is equal to C1 plus C2 minus T1, right? So our C1 is 2161.39 plus our C2 here, which is 998.88 plus minus T1, which is 998.88. Okay, so our PB, the balance loading, will be equal to 2161.39 kilo Newton. Okay, so this is our answer for the balance loading. Okay, PB. Alright? So next now, class, next now is the EB. How to solve? Okay, so letter B na tayo. Solve for EB. Okay? So let's draw the diagram again here para mas makita nyo na malinaw. Ngayon, lagay natin, no? Ito yung centroid. So let's say this is the C2. Okay, we have here the C1. Okay, and this is the T1. And of course, we have here the PB. Okay? So, ang tinatanong, if this is the plastic centroid, so this is the EB. Tama ba? And this distance here from the centroid, okay, is what? Okay, alam natin na this is 300 minus 65. Tama ba? So, 300 minus 65. So, that is 235. Right? Nakuha ba? Baka nakuha 235. So, ito yun, di ba? Okay. This one, this part here. Okay, so the whole half here is 300. Tama? So, bawasan mo lang ng 65. So, you will get 235. Right? So, 235 to. Hanggang the centroid. And then, for C1, here, ilan to? Guys, ilan yan? So, can you solve that? So, bakit ko kinukuha yung distance nito? Ang gagawin kasi natin dito, we're going to have our moment here sa T1. Pag moment tayo sa T1, we will get EB. Okay? Pero yung mga forces na involved will be the PB, C1, and C2. So, for the C1, we need the force. Meron na tayo dyan. Ang wala lang is yung moment R. So, we need to get this value. Of course, ganun din sa C2. Okay? So, alam natin ng C1. Okay, so C1 is how you get this. So, this, let's say this is X1 and this is X2. Tama ba? For X1, for the C1 here, ano yung magiging equation natin? So, X1 will be the 535. Ba? 535 muna, yung D. Okay? Bawas mo ng A all over 2. Tama? So, ang A natin or AB natin is 269.08 divided by 2. Tama ba? Okay? Yes. Right? So, that is... So, nanggaling ito sa D minus A all over 2, ha? Yung x1 natin. So, that is 535 minus 269.08 all over 2. So, we will get the answer of the distance of 400 sa 400.46 as your x1. And then next is x2. So, ang x2 natin, ang galing sa D minus D prime. Yan. Yan yun. Okay? So, D minus D prime. Alright? So, 535 minus D prime, 65. If you recall, no, your doubly reinforced, that is 470. Okay. So, we can now get or solve EB. So, summation moment lang tayo, class, sa T1. Okay? It's equal to 0, positive, clockwise. So, we get PB first. PB, multiply the moment arm, 235 plus EB is equal to, okay? Equal siya dun sa, ito, yung mga opposite, no? Yung C1. So, C1, X1 plus C2, X2. Tama ba? So, ang PB natin dito, class, is 2161.39 times 235 plus EB is equal to C1. Our C1 is 2161.39 multiplied by X1, 400.46. Plus po natin ng C2. Ang C2 natin is 998.88 multiplied by 470. Okay, so we will get EB using shift solve class, no? Makukuha na natin yung EB dito. Take note, tumalabas din sa board to. Kaya marunong din, just recall lang, no? Recall mo lang yung principle ng beam natin. You will get the balance loading of a column. Okay? So, lumabas na X sa akin is 382.669. Okay? 382.67. Okay? 67 mm. Okay? So, this is our answer for balance eccentricity. Okay? So, ngayon, bilang conclusion, no? So, if we're going to put a 2161.39, okay, from a distance 382.67 from the plastic centroid of this column, okay, the column tension side will yield at the same time as the concrete, okay, in the compression side. Right? So, yun yung conclusion, okay, or summary na nakuha na. Alright? Yes. Okay. So, ganito rin yung magiging concept natin, class, is pagkuha ng allowable PB if given naman yung eccentricity. Okay, yun yung i-discuss natin. Okay, so we will discuss in the next video Okay, how we will get the loadings, okay, what or the nominal load of our column if given yung EB. Okay, given yung EB. Alright, so that is for the next videos. Thank you very much. So see you on our face-to-face.